now we have to see what is that your reflection of your waves over here. So obviously the waves are going to get reflect. So when it hit or incident on a rigid surface, so it is going to just, so these are the waves which are going to travel, and now it just hit the this wall, rigid wall. Now it just change in the angle. Yeah, so there is a change in the so phase shift. So there is some phase shift will occur when it hit that. Yeah, and again it get back to just move again along its backward direction. Yeah, so that is what we can call it as a reflection of your waves. So this is how in the reflection of wave, if the wave is reflected from your rigid body or rigid boundary, so there is a phase shift of your pi, and again in case of your some open area, open boundary, so there will not be any phase shift, but it will get back. So it will move in the backward direction. So that is what we can say about this, your transmission and reflection of your waves for this particular case. So the frequency of wave is not going to change when it just travel from one medium to another medium, or when it just get incident on that your rigid surface. Again it will get reflected with the same frequency over here. So that is what we can say. So this is amplitude of reflected and transmitted wave. Although you can say that, so this is how the before and after getting, it will just get reflected from that your surface over here. So now based on this, we have to see a very important that phenomenon which we call as a principle of superposition. So where two waves are going to interfere with each other, and because of which there might be the constructive interference, in which the amplitude you will get maximum, or where there might be possibility that they are out of phase and you will get minimum amplitude. So that is what we have to see over here. So you can see in the diagram also the two pulses approaching each other. Again they just get overlap. So here it will just produces the maximum amplitude. So here let's say the amplitude is less, but because of this overlapping, the amplitude has got again increased, and again they move in the opposite direction. So this is how we can show over here also. So this is for example, so the pulse, that is nothing but overlap. So precisely for an instant, so you will get the resultant amplitude which is 0. So where you can say that, so they are just out of phase, and you can say that the amplitude will get 0. So the same thing, the superposition principle, when the two waves pass through the same point, the displacement is the arithmetic sum of the individual displacement. So at a particular point, you have to calculate what is the individual displacement produced by your each wave, then just do the addition, the vector addition for that, and you will get the resultant displacement at that particular point over there. So this is how we can just try to see over here also. So let's say this wave is moving towards the right side. Now just try, even if you see that, so this is the wave which is moving on the left side. So consider any one point, assume that, so this is moving on the left side. So just they are going to overlap, and which will produce your the various intensity or amplitude. It might be maximum or it might be minimum at a particular point over there. So now what is this principle of superposition? It states that, so let the resultant amplitude, so that is given by your A. Again this is, you can show that, so this is the resultant wave who is given as the same form, y is equals to a sine of omega t plus del over here. So similarly you can prove in the similar manner also. So you can just prove in the similar manner also. So this is y1 is equals to a1, that is a sine omega t. So y2 is equals to a2, your sine omega t. So the resultant will be y is equals to y1 plus y2. Just add those two your waves. So this is a1 sine omega t, a2 that is your sine omega t. Okay, so if you just do these things finally, so you will get the result for that. So that is a 2a cos kx, and that is sine omega t. So you have to just, so this one also you can say that, so this is the wave which is moving on the right side and one is moving on the left side. So this one omega t minus kx, and this one is omega t plus kx. So here also you have to just change according to that one. So let's say for example, if I just make it, that is your sine omega t minus kx, and this one again I will say that. So obviously this is minus kx1, and then this is your a2, your sine of omega t plus kx. Yeah, so just use that result of your sine c plus sine d and you will get, so this is the resultant amplitude, yeah, at any point. So that is given by y is equals to 2a cos kx into sine omega t. So the resultant wave is also sine function, but the interesting thing is that there is an absence of term, that is a kx omega t minus kx plus kx. So you can say that it is not moving, it is just vibrating about its mean position. So that is the most important thing over here. So it is just the particle vibrating about their mean position, it is not propagating. Yeah, so that is the interesting thing, and that is according to which I can say that, so here it is just a vibration of particle will take place, and this is how you will get the result for the same also. So that a is equals to square root of a1 square plus a2 square plus 2a1 a2 cos phi, and del also you can write it down, that is a2 sin phi upon a1 plus a2 cos phi. So this again the principle of superposition, the maximum intensity for equal amplitude. So maximum intensity is 4a square, the intensity of equal amplitude, you can write it down that you will get 4a square cos square of phi by 2. And the part difference is again that maximum intensity is n lambda, and for minimum intensity is 2n plus 1 lambda by 2 over there. So this is how we can show the constructive interference. So the waves are in the phase, so either they reach their maximum or minimum value at the same instant of time. So that is what we called it as a constructive interference. Then destructive, they are out of phase. So one is just increasing in the positive direction, one is increasing in the negative direction. So they are out of phase, which will produce your minimum intensity over here.